Welcome, and in this video we're going to discuss logarithms, and so you might remember these, maybe you don't, but really we want to be able to do two things. We want to be able to get a graph of a log function and solve log equations. And so really let's just begin with the definition. And so we've been discussing exponential equations. Now, we mentioned when we were solving those that there was one way where we had the same bases and then we set the exponents equal to each other. Well, generally that can't always work, right? Because we have something like 2 to the x is equal to 3. Well, there's no way you can get those to the same bases, so we have to have a different plan, and that is to use its inverse function, which is a topic from pre-calc, so we're going to leave that for pre-calc, but we're just going to define a logarithmic equation as such. So we have a is a fixed positive number. Some books use B, I use A, tomato, tomato. So it's a positive number different from 1. Okay, and so then we say the log function with base A is defined as the inverse of the exponential, This is the big thing. Okay, if we have something like x is equal to a to the y, that would be our exponential, right? Okay, when we write that, that is actually the same as y is equal to log base a of x. Okay, so notice here that we have a as the base of the exponent, and really what we're doing is we're trying to express that value of y in a different form. And so this is saying that y is a logarithm, and so really all a logarithm is it's the exponent that we need. Okay, now this, I think this is so incredibly important that I don't have any tattoos, but if I were to have one, I would have this, because this is like the absolute number one thing that you need to know from college algebra going into pre-calc. So I'm going to refer to this affectionately as the tattoo. Okay, so whenever you hear me say the tattoo, that's what this means, is remembering this conversion. Okay, so then in this video, the rest of the video, we're just going to work on completing these tables, and I'm going to do the left table with you, and then you're going to ask a series of quiz questions to help you figure out the right table. Okay, so in logarithmic form for the first one, so this is 625 is equal to 5 to the 4th. True statement. If we were to write that as a log, though, what this ends up being is that, okay, so base of the exponent is the base of the log, so it would be log base 5, and then it would be of 625 is equal to 4. Okay, and then similarly, b squared, okay, this is just going to be log base b, which is the base of the exponent, of this, of 3.2, is equal to 2. Now, some people, when they learn this, they told me that there's this crazy circle method, okay? And yes, you can use the circle method. The idea of a logarithm converting is you take the base, so it'd be log, and then base of the exponent of the answer is equal to the exponent. That's the way some people learn it or remember it, and hey, if that works for you, great. I'm going to use the tattoo. But no, the circle method is another one. So here, I'm going to have you just pause the video and try this. 4 to the e is equal to n. Okay. And if you did that, you should get log base 4 of capital N is equal to e. Okay. Now we're going to go the other way because, well, why not? And actually, you need to be able to. So this is going to be 5 to the d is equal to 8. So again, base of the logarithm. Circle method actually works here too. You would just do the base of the logarithm to the answer is equal to the input. Okay, and then this is going to be 2 to the 3 is equal to 8. That's another fun one. Okay, now try the last one on your own. And if you do it, you should get pi to the 4th. I don't know why it's not writing there. There's pi is equal to 2x. Okay, something like that. All right. And the last little bit here is going to be a quiz question. There's a lot of them because you need a lot of practice. Okay, so let's try each of these in the quiz.